your book you have only 2 by 2. So can you check that in first chapter?
Yeah, ma'am. Yeah, 2 by 2 is there, but at the same time, the professor here just gave 3 by 3 also as
Okay,
additional.
okay. Okay,
That's
all
why.
right. And you have next topic which is inverse
Inverse.
inverse of a matrix.
Mm.
So let us understand it. Okay. Matrix. Let us really use the inverse of matrix to solve system of linear equation further. So inverse of matrix, so its formula is A inverse is equal to 1 upon adjoint of A in, sorry, 1 upon determinant of A into adjoint of A. Okay. 1 upon determinant of A we have done already, and
Okay.
this is adjoint of A. So first of all, we need to know what is adjoint of A. So for 2 by 2, then further we'll do for 3 by 3. Because for 3 by 3, it has a long procedure to find the inverse of A. So we use that 3 by 3 to solve a system of linear equation so that you can understand like step by step each and everything. There is lots of background noise on your side. Can you
Yeah,
check that?
I'm in a hostel. That's why.
Okay. So
Yeah, the
adjoint
noise.
of A for 2 by 2, adjoint. Let us know. For first 2 by 2.
Yeah.
So let us understand by using an example. If we have matrix A is equal to having element A11, A12, A21, A22. So adjoint of A is,
Yeah.
see, just interchange these elements. Interchange these elements and just change the sign of these two elements, these. Okay. So this
Okay.
is the way to find adjoint of A for 2 by 2.
Okay.
So in adjoint of A, we have A22, A11, minus A21, and minus A12. This is adjoint of A. Got it?
So, so we need to just
For
change.
example, if we have a matrix like having 2, 3, 7, 5, then adjoint of A can be expressed as, so just interchange these elements and take opposite sign of these. Got it?
Yes, ma'am.
Yeah.
So why is
But
it
3
become
for 3 by
minus?
3 is completely different from this. So
So this.
we need to find system of linear equation also where we use inverse of A to solve that. So we use, let me check if you have this topic. You have eigenvalues. Okay. I'm just checking if, okay, okay, you don't have this topic. Okay, so let us, I'm telling you inverse of 3 by 3 because you don't have the system of linear equation to solve.
Okay.
Yeah. So I'm telling you the A inverse of 3 by 3. So this is adjoint of A. So let us find inverse of A by using an example, okay? By using this formula. By using this formula, let us understand to find inverse of A first for 2 by 2. So if we have like we have A here having these elements. Okay, so let us find the determinant of A for this. Okay, let us find it. So determinant of A, as I told you, just multiply. Uh, First of all, just write the elements in this form. And 2, 3, 7, 5, 2, 3, 7, 5, right in this form. Now just multiply these elements, then take minus sign, then these elements.
Okay.
So 2 into 5 minus 7 into 3. So we have 10 minus 21. So now we have minus 9.
Yeah.
Okay. So now let us find A inverse. So A inverse is 1 upon determinant of A into
Yeah.
adjoint of A. So here we have A inverse. Determinant of A is minus 9. So write down here 1 upon minus 9. And
Okay.
adjoint of A, we have 5, 2, minus 7, and minus 3. So this is inverse of A. You got it?
Okay. Yes, ma'am.
For 2 by 2. Now let us learn for 3 by 3.
Ma'am, just a question. Can't we don't need to solve this anymore. We can just leave it as it is.
Pardon? You want to do some more example?
No, no, no. We don't have to solve the equation, or we can just leave the equation as it is.
This one? No, no, no. No need to solve this.
Okay.
We need only in matrix form because we need to find inverse of matrix A. Okay?
Okay.
So no need to solve further. This is the
Okay.
required answer.
Okay.
Okay? So now let us find for 3 by 3. So let us take an example to understand that well.
Yes.
Take matrix A having elements 2, 3, 5, 1, 7, 4, 5, 6, and here 3. So first of all, to find A inverse, we need to check the determinant because a determinant shouldn't be 0. Because if we have determinant 0, obviously we'll get the undefined value. So let us check if its determinant exists. So let us find first of all determinant of A. 2, 1, 5 having the elements 3, 7, 6, 5, 4, 3. Let us expand it. So take the first value, this. Leave the elements of first row and first column for that. So we have these elements 7, 6, 4, 3. Now take the negative sign and take next element, that is 1.
Okay.
Now leave the elements of first row because this 1 is the element of first row and but second column. So leave
Uh-huh.
these elements and write the left.
3563.
Are you getting this point?
Yes, ma'am. 3563.
Now take positive sign and take this value. And just leave the elements of first row and third column, take these elements.
3754.
So, 3, 7, 5, 4. Now let us simplify. Do you remember? Just multiply these elements and subtract product of these.
Yes.
In
Yes,
this
ma'am.
way, let us find 7 into 3 minus 4 into 6 minus 1, 3 into 3 minus 5 into 6. Are you getting this step?
Yes, ma'am, I am.
So now let us solve further. So determinant of A, you have 2 into 7 into 3, 51 minus 24 minus 1 we have. So just multiply 1 with the same number, you get 9 minus 30 plus 5 into 12 minus 35. So now we have 2 into minus 3 minus this minus and this obviously we'll get here minus 21. So this will become positive because of
Uh,
this
minus one.
negative outside. So now subtract 12 from 35. So you'll get minus 23. Okay. Minus 6 plus 21 and minus we have. Now let us find the determinant of A. Are you getting these steps or
Yes, I
want
am.
to ask anything?
No, no,
Okay,
no.
so we have 121 minus 121 we have plus 21. So determinant of A is minus 100. That is not equal to 0. Okay, it shouldn't
Yeah.
be equal to 0. You can have a negative, positive, any value. It means we can find
Okay.
A inverse.
Okay.
Okay,
Yeah.
so let us find it. So to find A inverse, we need to find cofactors because
Yeah.
to find adjoint of A, we need cofactors of that. So let us find A is equal to having elements 175, 285 and 174, 174 and 563. And adjoint of A will be C11, C12, C13, C21, C22, C23, and C31, C32, and C33. And now we need to find these all values from C11 to C33.
C33.
Yeah. These are cofactors. So
Okay.
let us find them. So first of all, we'll find minors with the help of minus, then find cofactors. The first minor that is M11 means just leave the elements of first row and first column and write on
Okay.
the left. Got it?
Yes, ma'am.
21 minus 24 that is minus. So cofactor C11 is equal to take minus 1 to the power 1 plus 1. Means we'll add these values 1 plus 1. Okay. If we have C12, then we'll add on power of minus 1, 1 plus 2. And just
Okay.
multiply M11. So
Okay.
obviously this is even power, then we'll get the positive value. Means value of M11. Are you getting this?
So C11 equals to minus 1 plus 1.
So now M1 to find
Where did
M12,
we,
just leave the element of first row and second column.
ma'am, where did we get the minus 1 from for the C11?
Pardon?
For C11 equals to minus 1 in the brackets, where did we get that number, minus 1?
Yeah. This is rule to find because we'll add these values on power of minus 1. Okay, just multiply value of M1. Okay, so here 9 minus 30. So here we have M12 is equal to minus 21. And now let us find C12. To find C12, just put 1 plus 2 on the power of minus 1, just multiply M12. So you know
Okay.
here power is odd. So obviously we have negative sign. along with M12. Are you getting this?
Yes, ma'am.
So C12 will be minus 21, that will be 21. Now let us find the further values. From C11 C we need to find it.
You can't change the activity.
So we have to do this for everyone. Do we have to do this for all the numbers?
So first row and third column. Yes, exactly. Give the elements of first row and third column, and we have 3, 4. That is why I'm saying, because they rarely adjoint of 3 vertic lines. Yeah, and also not in your syllabus. But you okay, I'm telling you, not a problem. Now let us find corresponding C13. Minus 1 to the power 1 plus 3. Just multiply M13. So power is even. So obviously C11 is equal to C13 is equal to M13.
Yeah.
And now let us find, that is 12 minus 25. We have minus 23. This is also minus 23. Now let us find M21. Leave the elements of second row and first column. Second row
Yes,
and
ma'am.
first column.
And first
We
column.
have 1, 5, 4, 3. So 3 minus 20. So we have minus 17 here. Got it?
Yes, ma'am.
Now let us find C21. That is minus 1 to the power 2 plus 1 M21. So obviously power is also, you will have negative
Minus,
M21
yeah.
and minus 17, and then you can take 17. C21.
This will be
Now let
plus.
us find next values. Leave the elements of column 2, 5. Then you can get M22, obviously minus 25, and is equal to minus 19. And C plus 2 into M22. So obviously this will equal to M22, because power is equal, this equal to 19. So third one, we have here 8 minus 5. We have 3. Now let us find C23. That is minus 1 to the power 2 plus 3. So we have odd power. Obviously, we'll have negative of this in a step. Next, and 3, 1. Leave the elements of third row and first column. We have 1, 5, 7, 6. And we have 6 minus 35. So we have minus 29. And let us find 3, 3, 1. That is 1 to the power 3 plus 1 into 3, 1. So this will become equals to M31, because power is even. And
Yeah.
here this is minus 29. So C31 is equal to minus 29. Let us find the next value, M32. Now leave the elements of row and second column. We have 2, 3. So M32 We have 12 minus 15 minus 3. So now let us find C3 minus 1 to the power 3 plus 2 into M32. We have negative of M32.
Uh,
So we have 3.
yeah.
We have here 3 only.
Yes. Yes,
So
ma'am.
now we need to find one more, that is M33.
M33 and C33.
One third column, we have 2, 1, 3, 7. So we have 11. And C33 is equal to into M33. We have even cover, so obviously we'll have M33 is equal to which is 11. Now adjoint of A is equal to C11, C12, C13, C21, C22, C23, and C31, C32, and C33. Values of all of these cofactors, C1 is minus 3, 1, 2 is 21,
Yeah.
and let's see C 1, 3, that is minus
Minus
23.
29. 23. Okay.
So C21 is 17,
17. Then it's minus 19.
okay, minus 9,
19. And then minus 3.
and okay, minus 3. Now C31 is so minus 29
29.
and 3
Uh,
and
uh,
11.
yeah.
So inverse of A is equal to 1 upon determinant into A. So we have determinant of A minus 100 and take adjoint as minus 3, 21, 23, 17 minus 19 minus 39 minus 3 and 11. This is the required inverse of A. You got it?
Okay.
How can we find
Yes, ma'am.
for 3 by 3? Yes.
Yeah.
Now let us learn how to find eigenvalues.
Okay. Yeah.
Next topic and also the last topic of your this matrix.
Okay, ma'am.
How to
Yeah.
find eigenvalues.
Eigenvalues.
Yes. So to find eigenvalues, step first, follow the step this first. Mm, put sorry, okay, form the matrix A minus lambda into I. Step second, find the determinant of A minus lambda into I. Step 3, Put determinant of A minus lambda into I is equal to 0. And step 4 is solve for and just a second, I'm checking. This is the required characteristics equation. This equation is said to be characteristic equation.
Characteristic equation.
Yes. This A minus lambda into I is equal to 0. Now solve for lambda, and values of lambda are eigenvalues.
No, you can't play this card. So take
So let's do an example to understand this well.
No, you can't play.
Okay, I'm taking example from your book. Okay,
Done.
give me a moment.
Can I play? Number से ही खत्म करना है. Lightning है but चलाते एक बार.
See on page number 76.
Page number 76 one.
Page number 76.
उसका ग्रीन मना कर रहा है ग्रीन काट दी मार के तेरा छुट्टी है सुनता ही नहीं मैंने ऑलरेडी बोला था
पता नहीं 2 प्रॉब्लम पे गिरा था लास्ट में.
Just a second.
उसकी मार छुट्टी
They are using symbol here. This.
And what's that symbol they're using? It's something into C equals to Lara. Right?
हाँ लेकर
They are using the symbol like pi, capital pi. Okay.
Okay.
So you can use any symbol. Means they are denoting just a matrix. Okay. See, just beside the chapter 8, like in blue ink, let this pi denote the p by p square matrix. Okay. Yeah. So they are using to represent a matrix. So you can take any symbol. Even you, we can take that. So that using the symbol, let us do.
Yeah.
And we have matrix this 5, 1, 2, 4, and we need to find eigenvalues. Okay. So then let us form first like to find eigenvalues. We need to form the characteristic equation. Before that, we need to form this matrix. Okay, and that is equal to, I'm taking here this matrix, and lambda into I is identity matrix. We need to take here. I is identity matrix. So 5, 1, 2, 4. and just multiply here. So we'll get lambda here, 0, 0 and lambda. Now subtract from the corresponding elements. So we have 5 minus lambda, 1, because 1 minus 0 we have. So we get 1 also, same as 2 minus 0 is 2, and 4 minus lambda. You got it?
Yes.
Now let us form the characteristic equation.
Comment question posting.
Matrix, given matrix, determinant of that is 0. So now let us find determinant of this. Are you getting this step?
Yes, ma'am. I am.
Okay. So now we need to find determinant to form characteristic equation, which is 5 minus lambda. Okay, 1 here. Yes, 1, 2, and 4 minus lambda. Now just multiply these values, then take minus sign, then just subtract product of these values. So 5 minus lambda into 4 minus lambda minus 2 into 1 is equal to 0. So let us simplify. Multiply. So 5 into 4 we have 20. 5 into minus lambda we have minus 5 lambda. Minus 4 into lambda, minus 4 lambda, and plus lambda square. Minus 3 is equal to 0. So now let us simplify. Write down in order. Minus lambda square, minus 9 lambda, and plus 18 is equal to 0.
Okay.
Okay. So now we can solve by splitting middle term.
Okay.
So you got this step?
Okay. So you just split 9. Okay.
Lambda minus 3 and lambda minus 6. So lambda minus 3 into lambda minus 6 is equal to 0. So lambda minus 3 is equal to 0 gives lambda is equal to 3. And lambda minus 6 is equal to 0 gives lambda is equal to 6. So 3 and 6 are eigenvalues of the given matrix. Got it? These are the eigenvalues for the given matrix. Okay. So we have one more topic here, that is rank of a matrix. Just for rank of a matrix.
And I'm really into you. I have to talk to my dad. Wants to talk to my dad.
See, so rank of a matrix, how can we find? See the page number 73 in your book.
Just check it. 73.
Here, the rank of a matrix, how can we find? See, if rank of a matrix is given by the maximum number of linearly independent rows or columns contained in the matrix. What it see this first matrix?
Yes,
See,
ma'am.
both
3,
rows
7,
or
0.
column are independent of one another. Like they are different. Then we can take its order as a rank because the 2. And in second matrix, we can see both rows and in second matrix, we can see the second column is not independent of first because second column is just multiple of first. You can see here. Are you getting
3
this
into
point?
2 is 3 into 2 is 6, 2 into 2 is 4.
Yeah. So obviously, when we find its determinant, then we'll get 0. Okay. So yeah. So this is its rank is 1. I'm telling you on whiteboard what it means. When we find determinant of any matrix,
changes to green.
its determinant is 0. For example, 3 matrix. I'm telling you an example. Like if we have 3 by 3 matrix,
अभी लेकिन कवर है ना ये। भाई तो 5 पे डालो वो वाइड डाल के लोअर सर्किट फिर 5 लास्ट में
then we will find determinant of that. Then if you will get determinant 0 of 3 by 3, then we'll reduce into 2 by 2. This means just by applying elementary row or column operation, we'll reduce into 2 by 2. Then again we'll find the determinant of that 2 by 2. Then if still we get 0 of the determinant, then again, it means its rank is 1. Are you getting this point?
Yes, one. So we have to break it down to 2 by 2. Then from there we have to break it down.
मेरे साथ जितने भी नौकरी मांग करवा पैसा बाकी है
Like if you have like 2, 3, 5.
अब नहीं अभी I already picked it
Let me check example because we can't take random example for that.
हो चुका ना बताया रे सामान नहीं मैंने ले लिया मैंने उठा लिया I studied it's like chromatic.
Okay, so let us take an example. Let A is equal to having elements 2, 2, 6, 4, 0, 8, 6, 2, 14. So first of all, we need to check its determinant. If it is 0 of 3 by 3, then we'll reduce it into 2 by 3 to find its rank. If its determinant is non-zero, then we can say its rank is 3. If rank of 3 by 3 matrix is non-zero, then we can say its rank is 3. And if we get determinant of 3 by 3 is 0, then we'll reduce it into 2 by 2. Are you getting this thing?
Yes, ma'am.
You are not my only brother.
So now let us expand it to find determinant. And 2, just leave the elements of first row and first column.
तीन कार्ड बाकी है, 9 कार्ड थे।
And now just leave the element of first row and second column. And then
मेरी है कुछ भी मिल जाए
2, 0, 8. So now just simplify it. 0 minus 16 minus 4 28 minus 12 plus 6. We have 16 minus 0. Minus 32 we have. Now minus 4 plus 64. Oh, let me check. If I made a mistake, I'm just checking. 2, 4, 6, 2 into 6, 18. So 2 minus and minus 4, 28 minus 12 plus 6. Okay, not 64. Obviously, when we'll add these values, so we'll get 96 plus and minus, so we have here 0. So determinant of this given matrix is 0 of 3 by 3. So now we need to just reduce into 2 by 2. Okay, so let us reduce it by using elementary row or column operation. Do you remember that?
Yes, ma'am. I remember.
So use another like wait for a while. Either just call it, just is equal to 2, 4, 0, 2. Just apply the row operation. So you have just 0 here, 4, and again 4, 0, 2. You got this? Just R2, R1 minus R2. And R3 minus 3 times of R2. So we have here 0, 0, and 8. So now let us choose any part of this.
और कैसे हुआ ऑब्जेक्ट की रूप
Let us find the determinant of like you can take this also. This is now non-zero. You know,
में
means we can choose any part of the matrix that is its determinant is non-zero. So we can choose this. So here determinant of this part is non-zero. So then we can define its rank is 2. Are you getting this point? Hello. Now
Yes,
we
ma'am.
need to see, yeah, we need to see that maximum elements we made 0. Okay. So now choose
Yeah.
any part of that. Or you can choose any part of along with this also. If you have non-zero determinant, then you can say its rank is 2. Okay.
Okay.
Then you can say
Yeah.
its rank is 2.
2.
Yeah. Since A is non-zero, so its rank is 2. You got it? If you get means if you don't have any 2 by 2 matrix here in this, that then its determinant will be non-zero. Then obviously you will have rank only 1.
Okay.
Are you getting this point? If
Yeah,
you
yeah,
don't
yeah.
have still any like 2 by 2 matrix in it, its determinant is non-zero, then we'll take only rank 1.
Rank as 1. Okay.
Got it? So
Yes, ma'am.
here we have one that have
Yeah, yeah.
non-zero determinant. So we can conclude that its rank is 2.
2.
Got it?
Yes, ma'am.
So to we'll start. If you want some practice materials, you can do practice with your book also. You do the calculus, means differentiation portion. Is it okay
Okay.
with you?
Yeah.
So when is your exam?
It's at the end of November.
When?
End of November.
End of November. Okay. So do you want daily class or just on alternate days? What do you say?
Ma'am, I'm okay with anything. It depends on your thing. If you want us to do daily, I can do daily, or I can do alternate.
Okay, okay. Okay, let me see the entire topics and tell you the how much classes will be needed. So according to that, we'll manage. If you need daily basis, then I'll manage for you. Okay?
Okay, ma'am. You go through the thing and let me know.
Sure. Okay.
Thank you, ma'am.